Welcome back students, welcome to the class. So today we will discuss the reactions of alkyl halides. The reactions of alkyl halides are mainly of four types. One is the nucleophilic substitution reaction, the other is elimination reaction, next is the reaction with the metals, and the last one is reduction. So these reactions we will now learn one by one. Now first we will take that reaction with aqueous KOH and aqueous NOH or with moist silver oxide. Now when react with aqueous QH supply enough hydroxyl ion, and according to the nucleophilic substitution, a strong base can displace a weaker base. So OH negative can displace almost all halogens. Okay, and why? Because OH negative is a stronger base than bromide ion, chloride ion, iodide ion, and fluoride ion. So what happens that it can displace or substitute any halogen in aqueous medium. So what does happen? OH negative will attack, bromine will be the leaving group. Okay, I am repeating once more. OH is a better base than Br. That's why it can displace halogens from their alkyl halide that is called as substrate. Okay, sure about that. Now, so first case we have taken is ethyl bromide. So ethyl bromide becomes ethanol, that is ethyl alcohol, while similarly, so the same reaction even by NOH, KOH and NOH both will provide you OH, that is hydroxyl ion. Now if benzyl halide react with aqueous KOH, then Cl will be replaced by what? Then the Cl will be replaced by OH, and you have the formation of benzyl alcohol. Now if there are two chlorine on any carbon, that is called as gem dihalides. So when gem dihalide react with aqueous KOH or aqueous NOH, both the halogens are replaced by OH. Now as you know that gem diols are highly unstable because one carbon atom cannot hold two hydroxy group. So immediately loss of water will take place and you have the formation of an carbonyl group. Remember that gem diols immediately in each and every case loses the water molecule and transform into a carbonyl group. Okay, and one more thing you have to understand that leaving group chloride, bromide, iodide or any other leaving group, that leaving group is also called as nucleophuse. It is called as nucleophuse. Now let's look at one more example. Take a toluene and react with chlorine in excess. That what can happen? All the benzylic hydrogen, they will undergo free radical substitution to provide you what? To provide you, okay, that is trichloro 1-phenyl methane. Okay, sure about that or not? When it react with aqueous QH, all the three chlorine will be replaced by OH. Now, as I told you, if there is two OH group on the same carbon atom, immediately they will lose and transform into a carbonyl group. So one carbonyl, this OH, so immediately transform into a carboxylic group. So when there are two OH group on one carbon, it will transform into a carbonyl group, that is carbon double bond O group. And if there are three hydroxy on the same carbon, they will transform into carboxylic acid immediately. Are you sure about that? Now next question is very important, that is Williamson synthesis. Okay, in this reaction the alkyl halide with sodium alkoxide or with sodium phenoxide forms ether. Okay, what has happened in this case? That alkyl halide, it reacts with sodium alkoxide. This carry negative charge. Why? Because when alcohol react with sodium, the H will be replaced by what? The H will be replaced by sodium and hydrogen gas will be released. So you have formation of sodium alkoxide ion. Now this negative charge is on the oxygen atom, and oxygen carrying negative charge is a very strong nucleophile. It will attack the RX bond, that is alkyl halide bond, and X will leave the system. NaCl form, okay, and you have formation of an ether. ROR bond will be there. For example, here in this case also, the negative charge on oxygen, it will attack this and iodide ion will leave, and you have formation of NaI. Similarly, in this case, this negative charge will attack this carbon and iodide will leave. So what you have? You have diethyl ether. Similarly, sodium phenoxide ion, okay, negative charge is carried by oxygen. It will attack the carbon of the methyl iodide and I negative will be the leaving group. So you had the formation of NaI. This compound is called as anisole, or it is called as phenyl or phenoxymethane. It is called as phenoxymethane. It can also be called as methoxybenzene. It is also called as, so anisole can be methoxybenzene, okay, or phenoxymethane. Now next question is very very important, that is intramolecular Williamson. It is what? Intramolecular Williamson reaction. Now what do you know intramolecular Williamson reaction? That O negative will attack the carbon within the, intra means within the same molecule, so O negative will attack the CH2 and Cl will leave the system, and you have a cyclic structure of, so this compound is called as furan. So it is called as what? It is called as THF, tetrahydrofuran. It is called tetrahydrofuran. Okay. Now if let us suppose you have 1, 2, 3, 4, 5, 6. So you have 1, 2, 3, 4, 5 and 6. So you have hex 5 in 1 all. So it is hex 5 in 1 all. If it react with H plus, this carbon will accept the proton and you have a positive charge on the carbon number 5. Then what can happen? The oxygen of the hydroxy group will attack this carbon and you have a formation of a cyclic ether. Okay, sure about that? This is called as pyran. So it is what this is called as pyran ethers. Okay, sure about that? Now reaction with the alcoholic KCN or AgCN. Now when alkyl halide react with KCN, then alkyl nitrile are formed. I am repeating once more. When alkyl halide react with KCN, nitrile is formed. Nitrile means the bond between carbon and carbon will occur. And when react with AgCN, then isonitriles are formed. Isonitrile means there is a bond with carbon and nitrogen will happen. Okay, so look at that. When it react with KCN, okay, this carbon and this carbon will form the bond. So carbon bond will be formed, and if you took AgCN, then you will take that nitrogen will attach to this carbon. Similarly, Look at that benzyl chloride. If benzyl chloride is taken, then carbon-carbon bond will form. And if nitrogen is taken, if isonitrile is taken, then what you have? AgCN is taken, then you have isonitriles. So why does it happens? Look at this question very carefully. The reason being that because AgCN is a covalent compound and KC is an ionic compound. Okay, and all of you know that cyanide is a what? Cyanide is a ambiguous agent. It can attack through two different carbon. So what has happened that this is AgCN. Now in case of AgCN, if you look at the structure of AgCN, then nitrogen is the only atom which contain a lone pair of electron. So it can only attack. So nitrogen has the only atom which has the availability of lone pair. So this lone pair will attack. But when you take KCN, then both nitrogen and carbon have availability of lone pair. Why? Because KCN being an ionic compound. Okay. Now carbon negative charge on carbon is a far more better nucleophile than lone pair on nitrogen. Why? Because carbon negative is more basic than nitrogen lone pair. Yes or no? Are you sure about that? And a stronger base is also a stronger nucleophile if they are in the same period. Are you sure about that? And if bulkiness is not the problem, if what else? Bulkiness is not the problem. Here it is not the problem because CN negative is present. So no bulkiness in the nucleophile occurs. So what has happened? That in case of AgCN, lone pair is present only on nitrogen. So that lone pair attacks R. And this RX bond is broken and a nitrogen carbon bond is formed and you had the formation of alkyl nitriles. In case of KCN, carbon has lone pair and carbon carry negative charge also. So this negative charge carbon, it will attack the carbon of the alkyl chain and you have RCN as the product that is called as cyanide. Now the reaction of cyanides are very, very important. If you take an RX, react with KCN, you have the formation of RCN. So what happens? So R become RCN. So it is an important method to increase the number of carbon atom in a given compound. So it is called as ascending the series. So cyanide reaction can be used as a method for ascending the series of an compound or making the next homologous. Okay, sure about that? So what happens that if you take an CN and if you use lithium aluminum hydride, it will completely transform into primary amine. Okay, but if you take water and completely hydrolyze that, then you have formation of what? Carboxylic acid. Okay, but if it done partial hydrolysis, then you had the formation of amide, that is acid amide. But generally the water is present in plenty, so in most of the cases complete hydrolysis takes place and the RCN transform into a carboxylic group only. Okay, so you get that here only R, here is R plus C both, so number of carbon atom increased. Okay, sure about that or not? So this is an important method to increase the carbon chain. Sure. If you take isonitrile, then what happens that it will give you a primary amine this and formation of this carbon will transform into formic acid. But if you do reduction, then it will transform into a secondary amine. So this question is very, very important. Okay. Now substitution by nitrite group. Now if you react the RX with sodium nitride, then you have formation of alkyl nitrite. This is alkyl nitrite. a carbon oxygen bond is formed. But if you take silver nitride, then you have nitroalkane. Now you have what? Nitroalkane. So why? Because potassium or sodium compounds are what? They are ionic in nature. But they are ionic in nature. So what does happen in ionic compound? Oxygen carry negative charge, 3 lone pair. The 3 lone pair on the oxygen are better nucleophile than lone pair on nitrogen. That is only one. Okay. So negatively charged oxygen is a better nucleophile than neutral nitrogen. So oxygen will attack the carbon and Br negative will leave the system, and you have the formation of ethyl nitrite in this case. Sure. In the second case, you can see that nitrogen has lone pair, oxygen has lone pair. But both of them are neutral now here. So neutral nitrogen is better nucleophile than neutral oxygen. Negative oxygen can be better nucleophile than neutral nitrogen, that is possible. But neutral nitrogen is a better nucleophile than neutral oxygen. So what has happened? All the 3 atoms are neutral, but nitrogen lone pair, it will attack this carbon and you have formation of nitroethane in this case. The answer to the problem is same, because sodium nitride or potassium nitride is ionic in nature, while silver nitride is covalent in nature. Now next question is with alcoholic QH or with sodium amide. Now with alcoholic QH or with amide ion, both of them are very good base. And good bases, they cause what? They causes always elimination reaction. And that elimination is known as alpha beta elimination. It is called as alpha beta elimination, or it is popularly known as dehydrohalogenation. Dehydrohalogenation means loss of HX. Okay, this reaction is preferred because there is an increase in entropy in the system, and on supplying heat, increase in temperature also. So increase in entropy and increase in temperature, these are the two favorable condition for elimination reaction. Now the elimination can be what? Elimination can be E1, E2 and EI. EI is what? Internal elimination. Remember one thing, SN1 always compete with E1 and SN2 always compete with E2. The use of solvent and the use of the heat is the major deciding factor that in which way the reaction will tilt. Okay, sure about that. If someone provides heat, then definitely entropy in the elimination reaction is positive. So what happens? That elimination is promoted because of the increase in entropy of the system on heating. Now generally alkyl halide give elimination product on the basis of Sadzev rule, or more accurately Zatsev rule. Okay, you call it Sadzev also. The spelling is this, Sadzev rule, or you can call it Zatsev rule. Same meaning. What is the rule state there? The rule states that the more substituted alkene is the main product or dominating product. Now what is that? It means that if an alkene has more number of alpha hydrogen around the double bond, then that product will be more. So always count the number of alkyl group around the double bond and then count the hydrogen attached to that. More the number of alpha hydrogen around the double bond, more will be the stability of the alkene according to the Zatsev rule. Why? Because more the number of alpha hydrogen, more will be the hyperconjugation. So what I am trying to say here, that if you have 2 chlorobutane here and alcoholic QH is used, then you had 80% what 80% formation of 2-butene and only 21 formation of 1-butene. What is the reason behind that? You have to deep look into the reasoning of that. What is the reason that here you can see that you mark the carbon containing the chlorine as the alpha carbon, and you have beta 1 and beta 2 as the two carbon atom immediately next to that. Now beta 1 and beta 2 are two carbon. Now what does happen here now? Here what happens that if beta 2 carbon is lost, then you have formation of 2 butene, and in this case you have 6 alpha hydrogen. But if you have hydrogen removed from beta 1, then you have only 2 alpha hydrogen removed from what? 2 alpha hydrogen removed from the 2 alpha hydrogen present in the alkene. So hyperconjugation is more in case of 2-butene and very much less in case of 1-butene. So what is the preference rule? The preference rule is that 2-butene has greater degree of alpha hydrogen, greater number of hydrogen, so hyperconjugation is more in them. That's why 2-butene is the major product here. Okay, so I told you that you have, for the detail, you have to go for E1, E2 and EI videos which are being posted. Now if you have alcoholic QH, okay, in which what happens, you have gamma carbon bulkier. If gamma carbon is bulkier, then Z-Sev rule is not followed. Hoffman rule is followed. I am repeating once more. If gamma carbon is bulkier, Z-Sev rule is not followed. Then what is followed? Hoffman rule is followed. That is the reverse of what? Reverse of Z-Sev rule. Okay. Here less substitute alkene is the major product. Now look at this alkene. Here gamma carbon is bulkier. Look at that. Gamma carbon is bulkier. So base cannot be attacked from behind, from the back side. So what happens? Base can attack beta 1 more preferred than beta 2. The base can approach beta 1 better than beta 2. So steric repulsions are present in beta 2 carbon, but no steric repulsion present in beta 1 carbon. So you had the formation of what? You had the formation of 4-methyl pent 1-ene. 4-methyl pent 1-ene as the major product in this case. The next case is when the base is bulkier. When the attacking base is bulkier, then it can't reach the hydrogen from the back side. Okay, then what can happen? Then it will attack that hydrogen which is easily available, and it means a terminal hydrogen can be lost more easily. So here in this case, okay, there are 2 carbon atoms there, but this hydrogen can be easily approached by this bulkier group, that is tertiary butoxide. Why? Because this carbon will have this methyl group around it, so that will produce steric hindrance to the bulkier base, that is, okay, tertiary butoxide ion. So tertiary butoxide ion can only approach the terminal carbon. It can't go the carbon which are present in non-terminal positions. Similarly here also chlorine is there and methyl is there. So now base is bulkier. So base cannot remove a hydrogen from there. Base can remove hydrogen from here, below positions only. So what happens? You had the formation of this alkene. But if you have normal base, then what can normal is? Now this normal base cannot face what? Cannot face the steric hindrance. So in that case you have the normal. So this product is Z-Sev product, and this product is called Hoffman product. Now look at the next case. Next case is a quaternary ammonium salt. When quaternary ammonium salt is heated in pans of base, then what happens? Then you have Hoffman product is the dominant product. Here in this case, you can have the formation of 2-butene and can have the formation of 1-butene. But In case of quaternary ammonium salt, this is the rule. What is the rule? Most acidic hydrogen is replaced. So look at that. Here in this case, what happens? Here in this case, there are two beta hydrogen are there. One is this, other is this. This is beta 1, this is beta 2. Now look at that. Now beta 2 has what? Methyl group behind it. But this beta 1 position, no methyl group is behind it. So beta 1 hydrogen is more acidic than beta 2 hydrogen. So you have formation of 1 butene as the major product. So remember that here in this case, that in case of quaternary ammonium salt also Hoffman rule is followed. In fact, quaternary ammonium salt, this elimination is popularly known as Hoffman elimination. It is called as popularly what? Hoffman elimination reaction. Now one more important product is that primary and secondary alkyl halide can be transformed into alkane by lithium aluminum hydride, but tertiary alkyl halide undergo elimination with lithium aluminum hydride. It means lithium aluminum hydride can't be used for tertiary alkyl halide. So if you have primary alkyl or secondary alkyl, they can be transformed into their corresponding alkane by using lithium aluminum hydride. But if you take tertiary alkyl halide, then what will happen? If you take tertiary alkyl halide, then because aluminum hydride provides you hydride anion, which is a very small base and one of the strongest base, it will take out alpha beta elimination and you have the formation of alkene. Okay, now in this case what happens? Sodium borohydride can be used. Sodium borohydride can reduce secondary and tertiary but can't reduce primary. I am repeating once more. Sodium borohydride also has one restriction that it can reduce only secondary and tertiary alkyl halide but can't reduce the primary alkyl halide. But there is one substance, that is triphenyl tin hydride or tributyl tin hydride, which can reduce all three types of alkyl halide, whether it is primary, secondary or tertiary. So tributyl tin hydride or trialkyl tin hydride or triphenyl tin hydride is one of the most excellent reduction agent in case of alkyl halide, because in all cases it will give you the corresponding alkane.